Okay, today I'm going to talk about investigating elasticity. What we're going to look at is a particular experiment, the results table, and we're going to see what the graph that accompanies it looks like. Okay, so first of all, I'm just going to introduce you to the experiment. Here we have a spring, and what we've done is this shows the same spring, but with different amounts of force added to it. Each time, more and more of these hanging masses have been added to the spring, and as you can see, the more force applied to the string, the further it extends. So the independent variable, the thing that I'm changing on purpose, is the force applied to the spring, and the dependent variable, the thing I'm recording, is how far the spring extends. So in order to measure the extension of the spring, I need to have a ruler which is attached to the stand like this. So then I could measure how far the spring extends. As you can see, this one here has got no force applied to it at all. So this is the spring before any force is applied. There's no force and there's no extension. Now let's say, for sake of argument, that each of these hanging masses applies a force of an extra 10 newtons each time I add one. So the first one has 0 newtons applied to it, then 10, 20, 30, 40. Now I'm just going to write this into the table here. Remember, force is measured in newtons. So I've got 0, 10, 20, 30 and 40 newtons. So that's my independent variable. What I need to do each time is I need to measure how far the spring has extended from its original shape. So at this point here, we have an extension of 0 centimeters. So this is what we're measuring now, the extension, nice and simply done using a ruler. So then the next one has extended a certain amount. Let's say that's extended 1 centimeter. This next one has extended a total of 2 centimeters. This one has extended 3 centimeters, and this one has extended 4 centimeters. Okay, so I'm just going to write these into my table. So this one is 0, then 1, 2, 3 and 4. So that basically is the experiment you need to do. Ideally, you'd like to do at least 6 different masses, but I'm just going to show using 4 for now. Okay, so what I'm going to do now is I'm going to show you what the graph looks like that accompanies this, because we need to be able to understand a couple of features from this graph. Now, the first very unusual thing about these elasticity graphs is the fact that the independent variable actually goes on the y-axis. Normally, the independent variable, on pretty much every other graph we ever do, the independent variable goes on the x-axis, but there is an exception when doing these extension graphs. And one of the reasons behind that is the fact that these graphs could be used to find the spring constant, and it's slightly easier to find the spring constant when it's drawn this way round. So that's why the graph looks a little bit weird, because the independent variable for a change is on the y-axis. Okay, so this is extension in centimeters here. Now, what we should find when we plot one of these graphs is, obviously I'm not using a ruler or graph paper here, I'm just doing it freehand, but hopefully we get the idea that we should have a nice linear relationship to begin with. So we should have a nice straight line here. Obviously I haven't been able to draw it perfectly straight because I haven't got a ruler, just drawing freehand today, but we should have a nice straight line. Now, if we continued this experiment, so we kept on adding more and more force, we would find 2 other things. We would eventually get to this particular point, which is called the limit of proportionality. Now what that means is after this point, we've added so many masses, so much force rather, that we no longer have a linear relationship. So it's no longer directly proportional. That is called the limit of proportionality. Now, if we keep going a little bit further, we get to another point, which is called the elastic limit. Now, what the elastic limit is when you've added so much force that the spring can no longer return to its original shape. It's said to be inelastically distorted. So after that point, the spring will not return to its original shape. It is now inelastically distorted. So that's an experiment to investigate the force effect on extension. This is what the graph looks like. Remember, it's a bit unusual because the independent variable, the force, is on the y-axis. Remember, we start off with a nice linear relationship, so a nice straight line. Then we get to the limit of proportionality and the elastic limit if we kept on adding more and more force to the springs. Thank you.